Hi class, in this recording we will be focusing on the lungs and the bronchial tree. So as we look at our lungs, here's just a generic lung. It's a right lung. We have different regions and parts of the lungs. We have this flat area on the bottom. We refer to that as the base, and it's kind of concave to make room for the contents of the abdominal pelvic cavity while it rests on the surface of the diaphragm, the muscle that separates the thoracic from abdominal pelvic cavities. The pointy end on the superior margin is referred to as the apex of the lungs, and it's going to extend to just above our clavicle to give you a frame of reference. We also are going to have costal and mediastinal surfaces. The costal surfaces are going to be on the lateral margins, pressed directly up against our rib cage, and the mediastinal surface is going to be on this interior margin of the lung, shown here, and this mediastinal surface is always going to point towards the heart. And at the hilum, here we have the hilum of the lung. The hilum is just a generic term that refers to any indentation in an organ where we have lots of tubes going in and out. So here with the lung, we have the hilum right here, and we're going to have blood vessels going in and out, and the main bronchus carrying air in and out. As we look at our right lung, it's worth emphasizing that the right lung is shorter. And the reason our left lung is shorter than the left lung is because our liver rises up partially into the thoracic cavity, not into, but pushes against the diaphragm, making the thoracic cavity a little bit smaller on the right side of our bodies. Our right lung also is going to have three lobes, the superior, middle, and inferior lobes. And these three lobes are separated by fissures, a horizontal and oblique fissure. The key thing I want to emphasize is that there's three lobes to the right lung versus two lobes to the left lung. The right lung is a little bit shorter, a little bit elevated up compared to the left lung because the left lung isn't being pushed up by the liver. However, the left lung has this giant indentation called the cardiac impression. And this cardiac impression is so that we can make room for the heart, which tilts towards the left side of our thoracic cavity. Because our left lung is smaller to make room for the heart, we ultimately will have the two lobes, a superior and inferior, versus the three lobes of the right lung. So let's look at a picture. Here we can see a left lung, and this left lung is going to have a much bigger indentation in it with a very large superior lobe and a much smaller inferior lobe down here, whereas the right lung is elevated up higher. Its base is hot. The base of the right lung is elevated relative to the base of the left lung, and the right lung has its 1, 2, 3 lobes to it. As we look at the lungs, left and right lungs, we have what is known as a bronchial tree. So when we look at the bronchial tree, I want you to think of the trachea as the trunk of a tree, and then all the branches down here, or the branches, as the rest of the tree. So you can think of the bronchial tree as an upside down tree. And from that main bronchus of the left or right lung, we're going to keep branching and branching and branching until we end up with approximately 65,000 terminal bronchioles. Now the first branch point is, and I'm going to shift colors here to bright red. The first branch point is the main bronchi or primary bronchi. Here, I'm drawing a big fat arrow to the right primary bronchi. This right primary bronchi is going to send all the air to the right lung. Or another way of phrasing it is all the air that goes in and out of just the right lung will go through this right primary bronchi. And then over here is the left primary bronchi. And it's going to send all the air into and out of the left lung. So these primary bronchi control the air that goes into and out of a left or right lung. Now, after the primary bronchi, I'll admit I'm a big fan of primary, secondary, tertiary. It's easier for me to remember. But we also could call them main, lobar, and segmental. So the main or primary bronchi send the air to a left or right lung. A secondary bronchi or lobar bronchi are going to send air to a lobe of the lung. So because the right lung has three lobes, the right lung will have 3 lobar bronchi, or secondary bronchi, and the left lung will have 2 secondary bronchi. And then when we look at the tertiary bronchi, this is the next branching point. Our tertiary bronchi are going to go to a segment of a lobe of the lung. And our segmental bronchi, or tertiary bronchi, are much more numerous. We have 10 on the right and 8 on the left. So we've gone from a few small number of secondary bronchi to a significantly higher number of tertiary bronchi. And we theoretically could go from tertiary to quaternary bronchi to pentenary bronchi, so on and so forth. But at a certain point in time, it just becomes not worth it. We get to a point where it's not worth it to just have more repetitive, iterative names of structures. So anything smaller than that tertiary bronchi, we're typically going to call a bronchiole, and we'll get to bronchioles in a subsequent slide. Let's first talk about a bronchopulmonary segment. This is one part of one lobe of a lung, and these bronchopulmonary segments are illustrated in this figure right here. So here you can see a lobe of the lung that's been broken up into different bronchopulmonary segments. And each of these are functionally independent of each other. And this is important because we're going to have membranes separating them from each other. And because these bronchopulmonary segments are separated from each other, this makes it harder for pathogens or cancers to travel from one part of one lobe to another part of that same lobe of the lung. So it helps to compartmentalize any disease states that may enter into our lungs. I would be remiss if I did not mention some cool things about the bronchial tree, such as the fact that you can have blood clots form in your bronchial tree. So, I mean, when you look at this slide, really the picture on the slide really jumps out at you. This right here is a blood clot. And as we look at this blood clot, we have a ruler up on top in centimeters to give you a scale of reference. This man had inspired his own blood. And then that blood coagulated in his lungs. And he started, after coagulating in his lungs, he started coughing violently. That's what expectoration is, coughing violently. And he coughed out a giant blood clot that was shaped like his bronchial tree. How cool is that? I'm kind of concerned by how young he was. But for the most part, I just think this is a fantastically awesome looking blood clot. This bronchial tree is going to have a pseudostratified ciliated columnar epithelium lining it. So we're still going to have a mucociliary escalator within our bronchial tree. However, the cells of this epithelium get shorter and shorter. They are slowly transitioning to a squamous epithelium, and the epithelium becomes thinner and thinner as we go farther and farther away from the primary bronchi, as we progress distally. And these divisions of the bronchial tree have lots of elastic tissue. This allows for us to cough and expel air from our lungs, or if we just go limp, we will passively expel air from our lungs. Oh, wrong button there. There we go, new slide. So as we look at those bronchioles are going to be anything that's smaller than the tertiary bronchi until we get to the terminal bronchiole. So as we're progressing, these bronchioles are very tiny. They are 1 millimeter or less in diameter, and they, instead of having a pseudostratified columnar epithelium, they have a ciliated cuboidal epithelium. And they're also going to have a very well-developed layer of smooth muscle lining them. Those bronchioles are going to divide to terminal bronchioles. And those terminal bronchioles are going to be the final stage of the conducting zone. If you don't remember, the conducting zone is all about moving air in and out of the body. It's not where we have gas exchange across a membrane. Our terminal bronchioles no longer have mucus glands or goblets, so we don't want to clog them up, the lungs up with mucus at this point. They still are going to have cilia, so if some mucus does get downed there, it can still move the mucus out. The cilia can still get rid of that mucus. Our terminal bronchioles are going to branch to 2 or more respiratory bronchioles. So here we have a terminal bronchiole, and that terminal bronchiole is going to turn into a respiratory bronchiole, and then notably after the respiratory bronchiole we have the alveolar duct come up. As we look at our respiratory bronchioles, the respiratory bronchioles, which are shown right here, lead directly to a large cluster. This large cluster is an alveolar sac with individual alveoli budding off of them. The respiratory bronchiole is going to be considered the beginning of our respiratory zone. And to review and refresh, the respiratory zone is when we have gas exchange across the membrane, when we have oxygen added to the blood and carbon dioxide removed from the blood, even though most gas exchange occurs within the alveoli themselves. The respiratory bronchioles are further branched to 2 or 10 alveolar ducts. Each alveolar duct is going to go to a larger alveolar sac. This large alveolar sac is a giant cluster of individual alveoli. So you can see there's an alveoli, there's an alveoli, there's another alveoli. All of these individual alveoli are connected through tiny little holes within the alveolar pores so that air can go from one alveoli to the adjacent alveoli. And that's all we have for this recording on the bronchopulmonary tree. If you have any questions or comments, please feel free to post them in the class discussion board or to shoot me an email. And as always, happy studies.